Alright, here we go. So today's lesson is Introduction to Sets. Three things you need to pay attention to. What is a set? First question. What types of notations do we use to write a set? And how do we combine sets? So if I have more than one set and I want to bring them together, what do I have to do to make that happen? The first one, what is a set? A set is basically a collection of numbers. Well, it's a collection of items. In math, we call it a collection of numbers. So it's a collection of numbers. Alright. We have a lot of different ways to write it, and we'll talk about that today. Most of these you're very familiar with. Alright, so a collection of numbers, and we'll answer those other two questions as we go on here. Alright. One of the things you're familiar with is inequalities. So if I have the inequality x is less than 3, something we've worked with before, that basically tells me that I have all the numbers less than 3, and since I don't have that equal to sign there, I know the number 3 is not included. When we graph this, we would generally put it on a number line. I make my number line here. What you've seen before is that we would use an open circle to let us know that the 3 is not included. But in this case, we're going to do things a little differently, and we're going to use a parenthesis to show it's not included. So I'll try to get a different color here. Alright, so I'm going to start at the parenthesis at 3. And I know that it's less than 3, so it's all the numbers going this way, and I put a little arrow on the end, so I know that's what I have. Alright, interval notation. Since I'm less than 3, my smallest number is negative infinity. Ugh. Ugly infinity sign. There we go. Negative infinity. And my highest value would be 3. Since it's not included, we go with a parenthesis. And infinity is always a parenthesis. It's never a bracket. We never include infinity, rather positive or negative. We'll come back to set notation in just one second. Let's take a look at another one of these here. What if we go with x is less than or equal to 7. We should have a really similar setup here. We graph it with our number line again. Alright, and then we are at 7, but instead of having the parenthesis, we have a bracket here. We have a bracket at 7, and we would go to the left, and we would have our arrow going that way. Interval notation, very similar. Still have infinity. This time we have 7, but we have the closed bracket. Alright, and last one here, if we have something like 3 is less than or equal to x, which is less than 8, and I have a closed interval here. I have the number line again. I am at 3, so my x is between 3 and 8. I have a closed bracket since the 3 is included. We draw it the other way this time. I have an open bracket at 8, so 3 here, 8 here, and then everything in between is shaded. Alright. And here, close bracket at 3, open bracket, parenthesis at 8. There we go. And we're all set. Alright, set notation. We use brackets here to denote a set. Since I'm working with the variable x, that's the one I start with. Then we draw a vertical line. That vertical line basically means such that. So I have x such that, and then in this case, x is less than 3. Alright. Same thing here, I would have x, and then I have my vertical bar such that x is less than or equal to 7. And last but not least, x, vertical bar, 3 less than or equal to x less than 8. I have all x such that x is between 3 and 8. Alright. A couple practice problems for you here. Let's see. Complete all the following for the inequality. -4 is less than x is less than or equal to positive 5. Graph it on a number line. Write using interval notation. Write using set notation. And the one on the bottom here is cut off a little bit. It says write the set notation in words. So how would you say that set in words? Alright. And the last thing we want to talk about here is how to combine sets. If I have set A and set B, we have two different means of combining them. We can do a union, which essentially amounts to listing everything that is in each set, but we don't list duplicates. So if I have A, and it looks like a U, but I don't really have the kickstand on there, B, that would be written as the set. We have only numbers that are repeated in each of them are, well, let's see, we have 3, we'll go with lowest number, 1, 2, 3. It's in both sets, but we don't need to write it twice. We just need one list of each number, each unique item in the set. So 1, 2, 3, 4, 5, 7, 9, and 10. So that would be the union of sets A and B. If I want to do the intersection, I now have the elements that are both in A and B. For the intersection of A and B, I have 3 in both sets, and I also have the number 5 in both sets. Alright, so we can have a union where we take all the unique elements from each one and combine them. We have an intersection where we take only the elements that are in each set. Alright. And then a couple practice problems here. You have the sets D, E, and F, and we're going to do the union intersection of a couple of them here. And then practice problem 3. We have sets A, B, and C, and we want to talk about whether or not these sets are equivalent. Whether or not these sets are equal. If we're really writing the same thing, it's good practice for our notation.